as I already presented by Kiran, thank you, Kiran, for this invitation to this prestigious conference. And I will expose today. It's not about a presentation, theoretical or practical sometimes, but it's about the sharing my experience and my journey of working on AI application from my PhD until now. So today I have a lot to discuss about AI, but today I will focus on how we can enterprise AI and apply this enterprise AI in governments or any enterprise. I will take just custom administration as a pilot and the approach that I will share with you, I prefer to share with you and have some feedback from you. It's for the objective is for balancing between privacy, budget, or optimization. So it's pleasure to share my journey and experience how I work with AI. I started working with AI during my PhD in 2010. At that time, I focused on creating ontologies to build a knowledge base for governments, what we call cognitive AI. The idea was to make data more expressive, which would improve decision making. In 2012, I worked with agents that could orchestrate various tasks. I combined agents with a knowledge-based system, and that was my approach to AI. While this idea was new and innovative, it was difficult to industrialize. People didn't understand it, and implementing a knowledge management systems require a lot of resources, experts, and time. This made it challenging to continue my work in that direction. In 2016, I tried something similar, but focused on Arabic language, which was an even bigger challenge. I had many questions at that time, like, what value does this bring? And why would anyone use it? I didn't have answers to these questions and focused mainly on the technology. I thought my technical expertise is the most important to develop an efficient AI applications. Starting from 2018, I shifted to working on more practical projects to answer this question, applying machine learning and deep learning to customs fraud detection. And I already presented in the first webinar in the same conference. I focused on the technology and the best practice, but in 2024, I realized that integrating AI into existing systems required more than just technology. The key questions were, why should we use AI? What will we gain? How does AI fit into existing systems? These were questions from others, not just myself. To motivate the adoption of AI application, I had to answer these questions. So, how to align artificial intelligence with enterprise architecture. Integrating AI into an existing system was not just about building a perfect model with a high accuracy. It's about understanding how to make AI work within the larger system. It's about seeing the bigger picture, how AI fits into the existing system and how it can be integrated in a way that benefits the organization. AI transform all enterprises. I have developed a set of applications, but I ended by various AI application. When I come to integrate it in the existing system, I found a lot of problems of the operational silos. Because I'm from the software engineering, I see that I have to follow a methodology. I have to know some frameworks to apply it for developing and integrating and deploy any AI application efficiently in an existing system. So the scope of our application was a pilot administration, that is customs administration. From the perspective of government, this administration is very important. Why? Because this pilot, it exemplifies the challenges and opportunities of AI integration. It operates at the intersection of government and enterprises policies, making it a rich environment for this project. Custom legacy system presents both challenges and opportunities. Our goal is to bridge the gap using AI while preserving core functionality. So, enterprise architecture ensures that the understanding of the existing system gives us a vision for how to align AI with an enterprise architecture and integrate AI system smoothly in this existing system. So to do that, I remember I was working in software engineering as architect before, and I remember a framework that I use frequently to identify I'm working on what. This framework called Zachman framework. This framework is enabled to answer a lot of questions about the implementation of any new system. It's enabled to structure this project, and it is the cornerstone that we can use in any development of application independently of its AI system or another system. So this approach breaks down enterprise architecture into 6 perspectives. This method allows us to address every facet of AI integration, from business strategy to technology deployment. For example, in fraud detection, the what perspective helped us to identify the data required to build a robust model. The how perspective clarified the processes and workflows, while the who perspective defined the rules and the responsibility of agents involved. By mapping out this layer, I was able to see how fraud detection integrates into the existing system and identify the gaps or inefficiencies. The Zachman framework also guided us in replacing a control-based system for fraud detection by an ML or machine learning AI-based system. For instance, in custom administration, the technology perspective enables us to design a new system that integrates seamlessly with existing workflows. This approach ensures that the new system not only meets current needs, but it's also scalable for future requirements. So how we apply this framework, or how this framework guides us to analyze the existing enterprise architecture. As you know, any enterprise architecture composed of 4 layers. For example, in the business layer using this framework of Zachman align AI initiative with strategic objective. Key use cases in custom include fraud detection, for example, automated risk assessments, and compliance and monitoring. We can identify all the process, and we can see which process is concerned by AI application. The application layer, it's enabled to focus on how AI interacts with existing system. It's enabled to include and integrate any AI models through API, for example. Data layers is the heart of AI. We must establish governance policies to protect privacy while ensuring data quality and accessibility for AI training and inference. The last layer, technology layer, addresses infrastructure needs, balancing cloud scalability with on-premise solutions for sensitive data, for example. So, applying enterprise architecture with analysis using this framework. So fraud detections enable us to understand the existing system, how it operates. The second layer enable us to understand how transaction is classified, for example, in form of a set of rules that represent patterns for machine learning models. Data layer enable us to see what data to collect, what privacy issues we have pay attention to them. And technology perspective enable us what technology will be compatible with the existing technology used for the existing approaches. I have a second example is about, for example, developing agents RAG system based on large language models. Also, enterprise architecture analysis enable us to identify where we can add some AI, generative AI-based application and how to integrate them, or the enterprise architecture has some application in this direction. If not, we have to develop something from scratch, adapt the enterprise architecture, and then develop our, for example, agents. So here, the Zachman framework helped us to understand the task stakeholders, workflow involved. For example, I analyze how external users, stakeholders, like those outside of the organization, will use the system. This allowed us to identify key requirements, such as where to integrate the new system and how to ensure supports decision making. From technology perspective, the framework enables us in this use case to design the system as an API to integrate seamlessly with any part of the system, existing system. This API can be used for business, for example, BI intelligence, to analyze and to make some decision, to detect fraud, and so on, with the respect of regulations and so on. But this to successful this implementation of this technology, we have to define the scope. As you know, in this framework here, we have something perspective called scope. So we have to make some scope for this to define the good scope, or what I call awareness, context awareness, or to define what kind of data around this context. It's about the data quality. So we have used domain-driven design to improve the data quality, to prepare data, to be sensitive to the domains, and to be a context awareness. So domain-driven design, it enables us to prepare a high-quality data set for fraud detection, for example, and the risk assessment by focusing on the core domain and its subdomains. Domain-driven design helped us to structure and organize data in a way to align with real-world process. For example, in machine learning system, it enables us to collect a very good data. So we don't have a lot of tasks of cleaning. It helps us to, for example, prepare some patterns and make this pattern, the detection patterns, by these models of machine learning very easy, and it helps us. And another aspect is about the AI explainability, because the process of, for example, fraud detection is not just about the scoring and, for example, select the first one or the 10 one. It's about to explain why it's a fraud, based on regulation that or litigious regulation that govern this process. We can't say, for example, this is a fraud and that's all. We have to explain it. To explain it, we have to use data from regulations to know why this system detect that is fraudulent, from transparency, and for example, have a good decision making. So we arrive to the steps of how we can implement this approach. How can this approach direct us or oriented us toward implemented or good AI systems. So combining AI, enterprise architecture analysis, using Zachman grid and domain-driven design, it enables us to identify steps to make the development of AI systems efficient for an existing system. The first step is about analyze the existing system. We start by analyzing the current system using AI analysis and the Zachman, as explained before. This helps us understand the organization, structures, processes, and data flow. It also identifies gaps and inefficiencies of the AI can address. As explained before in the second, I think, presentation, Sometimes why we need to develop agents if human can, for example, achieve this task more efficiently than agents. We don't need AI. If, for example, we have a privacy problems, we have to see if AI it's important in this case. We have to explain, we have to motivate this system. And the second step is define AI rule and use case. For knowing which use case needs an AI application, we have to decompose the system. To decompose the system on subdomains. Here we use domain-driven design to identify any use cases in the existing system and to identify what data around the use case. The third step is applying domain-driven design for context awareness. It's important here. For example, in case of customs administration, we have a lot of domains. We have domain about declaration clearance. We have domain about risk management. We have domains about legislation and so on. So each one has a context different from the other one. So how we can limit this context and be awareness to this context. So, for example, for machine learning, for fraud detection, use, for example, the domain of litige or regulations. So here we have to integrate the both machine learning and an agent that can express what the litigious or regulations behind these fraudulent cases. The first step is about the defining the data with a good quality for AI models. Of course, we have a lot of privacy issues here. We have to care about them. And this fifth steps is about implementations of AI architecture. And here come, when we develop an AI, it will be standalone, it will be an API, or a new system that will be integrated after in a process among this process of enterprise. We have to reflect how to integrate efficiently in this application. And sixth step is about monitoring and improve AI models. So here we establish monitoring mechanism to track AI performance and continuously refine models based on new data and business needs. And the previous presentation is talk about a lot of metrics that I found very, very interesting to work with them to monitor any AI application after deployment. So what are the challenges has been addressed by this approach? The most critical challenge we faced was about data privacy and security. I'm so sorry, it's yeah, data privacy and security, especially given the strict legal constraints governments must adhere to. For example, for data collection, transaction data is encrypted using TLS, for example, and collected from trusted sources. Data processing, personal identifier are pseudonymous, and access is restricted to authorized fraud analysis. Data storage, for example, here we have to encrypted database and compliance. The system are there with internal and external laws for example, to audit and ensure compliance with the existing laws. That's from the perspective of security and privacy. For example, for interoperability. So in the part of interoperability was addressed through scalable infrastructure. So here we have a scalable infrastructure and technology compatibility, ensuring the new system worked seamlessly with existing system. For data management, for example, handling the vast amount of data required, it enables because we know which data we will integrate in such application, X application, Y application, and so Y applications. From the perspective of resource leveraging, we know by the question of who integrates in, the people integrate in such, for example, process, we know we have to make some skills gaps or talent acquisition or collaboration with external providers and so on. The budget issues. So in the budget issues here, what we have the problem, for example, here of finding some balancing. And here, for example, in developing of fraud detection application, we face significant challenges. Collecting and processing large amounts of data requires substantial storage. So we have here to choose to do on-premise solution or cloud solution. However, governments often resist cloud solution due to privacy concern, pushing us toward on-premise infrastructure, which comes with high upfront costs and ongoing expensive. Additionally, building and optimizing AI models demand high-skilled experts, which further increase costs, while partner, for example, with external providers can offer ready-made solution. It raises concern about data privacy and control. To balance this factor, we use a cost, what we call, for example, a cost-benefit analysis. This helps us decide between options, weighting the trade-offs between costs, privacy, and performance. For instance, we evaluate whether to invest in on-premise infrastructure or partner with trusted provider, ensuring compliance with privacy laws while optimizing the budget, for example, and so on. And this is just the first version of our guide toward developing a comprehensive AI enterprise guide, but it's not yet finished. So just I want to share that we start with identify strategic alignment. Start by identify the goals and value added to the existing system. What problem are we solving? For example, in fraud detection, the goal might be to reduce false positive while maintaining high accuracy. Decompose complexity, break down complex process into smaller manageable subdomains or sub-processes. For instance, in custom administration, we can separate clearance, declaration, risk assessment, and compliance checks into distinct workflow. Define use cases, clearly outline the use case for the enterprise. For example, in fraud detections, we have the use case may include real-time transaction, monitoring, anomaly detection, and case prioritization for investigator, for example. We have 3 processes here integrated in this machine learning, for example, application. Conducts assessment and feasibility study. Analyze the existing system, data availability, and compatibility with current technology. Ensure the solution complies with international and internal laws. Select the appropriate model. For example, for machine learning, we have used a lot of models, but not any models can work efficiently. Ensure the model with the data, we will feed it. Quality, quantity, and the relevant integration and deployment. Plan how to new system will integrate with or replace. For example, we will replace an existing system, or we will integrate a new API in the system. It be standalone application also, or will it communicate with legacy system via APIs? For example, in fraud detection, system may replace an outdated rule-based system. So, continuous development and deployment. Here, implement a robust process for continuous improvement. This is from the agile application from software engineering. And in our case, we have, according to this approach, so I will, to be honest with you, in our first work, we started just without this approach, just from the technical stuff of AI. We want to discover what AI can bring to this to our work. So I start working in the first work about building a knowledge base using, for example, large language model with a lot of models, trying them for a lot of use cases, I ended by Osiris application that I can integrate them. And we work also in fraud detection projects using a lot of models. And the both works, I already presented them in the same conference, the first webinar and the second webinar. So, but the problem here was really related in the last step, how I can integrate the both projects. And there were very big projects ended by a project based on agents. So here I decide to define a framework and to develop any application based on AI. And when I make this framework, I make some test bed or in the pilot application, fraud detections and RAG-based system and the RAG-based system. So in this use case, for example, for fraud detection, we addressed the challenge of detecting fraud in legacy custom system with structured trade data using machine learning, and we built an anomaly detection system that identify unusual patterns in this transaction, track behaviors, and assign a risk score. The system integrates seamlessly into the existing custom workflow in real-time API. But the real power lies is adaptability. The system continues to, for example, to evolve, and new fraud pattern can be detected. The second use case, it was the first use. The second and the first use case in this the second pilot was about custom question and answer about products classification. So here we develop a chatbot that can be used in any parts of the existing system. So that was our bot approach, where we have applied the approach of aligning this AI application with the existing systems. So here my conclusion. So integrating AI or developing AI for an existing system is not very easy. We have to have an overview of the big picture in the system, and then to identify the scope of, or identify the context in which we want to develop a specific or application. Then we have to think how, for example, to make some balance about using, for example, models, because models require a lot of resources. If we want to use a very optimization, for example, or very efficient models, we have to pay more. If, for example, the use case need, for example, for fraud detection, it needs some investment, it needs some budget. But for a RAG system, we don't need, for example, a big budget. We can find some balance between, for example, on premise or on cloud. We can decide is the data it's private, so where we can't make something because government engineer doesn't trust cloud solutions. So here we can develop on premise. We can optimize the resources what we will use, and then I hope this approach and this framework can help any enterprise to study and to analyze before the existing system, and to see how to integrate AI and them to find some balancing between budget and optimization, and also for privacy. Thank you for your attention, and I wish I present because it was because my presentation was before, so I don't